logical connectors, and Venn diagrams. The logical connectors and or can be used to describe an event. And means the intersection of two sets, written as A intersection B, is composed of elements that are common to both sets. So something is in both set A and in set B. In the case of OR, it means the union of two sets, which is written as A union B, is composed of all elements in either A or B. We can use a Venn diagram to represent these possibilities. One thing to note, we use the omega symbol to represent our sample space, which is the list of all possible outcomes. This signifies that what is shown in the Venn diagram represents the whole of the sample space. So you can see here, we've added the omega symbol to indicate that everything inside the box is the sample space. So everything within the red circle is part of set A. And everything within the blue circle is part of set B. However, the area where they overlap is the intersection between the two sets. Another way of looking at this is that everything that is in this part of the red circle is only in set A, and everything that's in this part of the blue circle is only in set B. Everything that's in the overlapping area is in both A and B. As I said, that's what we call the intersection. And finally, everything that is outside of both of them, I won't color this all in, but everything that's outside is not in set A and not in set B. We'll talk more about how we name all of this stuff in just a moment. Let's look at an example. Ms. James asked 30 students the following questions. 1. Do you travel more than 30 minutes to get to school? And 2. Do you have a job? The results of the survey are presented in the table below and depicted in the Venn diagram. Let's look at how it would be depicted. We'll start with the 8 students who responded yes to question 1 only. So those 8 students go into the travel zone. Now the students that responded yes to question 2 only, they end up in the blue area. The 7 students that responded yes to both question 1 and question 2 are in the space where they overlap. And finally, the students who said no to both are in the space outside both circles, but inside the black box. Let's look at another example. You're rolling a 6-sided die where the faces are numbered from 1 to 6. Create a Venn diagram to represent the events A and B as identified below. So event A, which is the red circle, is rolling an even number. Event B is rolling a number larger than 3. Let's go through each number from 1 to 6 and see where they should end up. So the number 1, it's not an even number, so it would be in event B, except that it's not larger than 3, so it would fall outside. The number 2 is an even number, so that should end up in red, because it's less than 3, so it doesn't qualify to be in blue. The number 3 is not an even number, so it's not going to be in red. So we try to put it in blue, but it needs to be larger than 3, so 3 can't go there either, so it also ends up outside the 2 circles. The number 4 is both an even and a number larger than 3, so it goes in the intersection of the 2 circles, the place where the 2 circles overlap. The number 5 is not an even number, but it is larger than 3, so it goes into the blue circle, but not in the overlapping area. And the number 6 is an even and larger than 3 number, so it also goes in the overlap. Let's back up again and look at how we got there. Event A is rolling an even number, so that was the numbers 2, 4, and 6. Event B is rolling a number larger than 3, which we said was 4, 5, and 6. Now, A intersection B, that's what we were defining here. It's the area where the 2 circles are overlapping. So A intersection B is 4 and 6. And A union B corresponds to all the numbers that are in either event A or event B. So that is 2, 4, 6, and 5. You can also create Venn diagrams with more than 2 circles. Let's take a look at an example. Ms. James asked 30 students the following questions. Do you own a cat? Do you own a dog? Or do you own a bird? The results of the survey are presented in the table below and depicted in the Venn diagram. So we're going to build the Venn diagram. So those who said yes to cat only were 4, and we put them into the cat only area. Those who said yes to dog only end up in this area of the blue circle. The 3 students who said yes to the bird only end up down here. Now those that said yes to a cat and dog. So that's where the red and the blue circles overlap, which is right here. Yes to a cat and a bird. There was 1 cat and bird combination, so it has to go all the way around to over here. And a dog and bird combination is right here. And there were 0 yes to cat, bird, and dog. So as shown there, there's nothing where all 3 circles overlap. And those who had no animals at all end up out here. So they're still part of the solution space, but they're not within any of the circles. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.